All of these things look different, right? But look closely. They all have something in common. On the left, we have got a chocolate bar divided into neat parts like 1/2, 1/4, even 1/64. In the middle, there is a gold coin marked 0.50 grams. On the right, we have a calculator. It shows 0.333 repeating, a decimal that goes on forever in a pattern. So, what connects all of this? They are all examples of rational numbers. Rational numbers are numbers we use every day. Like when you share a chocolate bar with a friend, each person gets half. That's 1/2. And guess what? That's a rational number. Scored 8 out of 10 in a test? That's 8/10. Another rational number. So, what is a rational number exactly? It's any number that can be written as P by Q, where P and Q are integers and Q is not 0. Look at some examples. Fractions like 3/4, whole numbers like 2 and 0, even negative numbers like -5. Now let's talk about decimals. Students often think decimals and fractions are totally different. But actually, many decimals are just another way of writing a fraction. Imagine this. You buy a candy for 50 paise. That's half a rupee. So 50 paise is really 1/2. Or say you get 0.75 rupees back as balance. That's the same as 3/4. These are called terminating decimals because they stop after few digits. Now comes something a bit tricky. Repeating decimals. Let's say you and two friends go out to a cafe and the total bill is rupees 250 and you decide to split it equally. So 250 divided by 3 gives you 83.333 and that 3 just keeps repeating forever. But this is still a rational number because 250 divided by 3 is a fraction. So even though the decimal goes on, it has a repeating pattern. Same with 0.111. That's just 1/9. Or 0.666, which is 2/3. Repeating but still rational. Now that we have seen how rational numbers behave, let's meet a very different kind of number, the irrational numbers. These are numbers that cannot be written as fractions and their decimals do something really strange. Let us start with square root of 2. Type it in a calculator. It gives you 1.414213. But if you keep going, the digits never stop. And more importantly, they never follow any pattern. Another one is square root of 3. Its decimal is 1.732050. Again, endless digits and no pattern. So, a good tip is non-perfect square roots like square root of 2, square root of 3, square root of 5 are all irrational. What about square root of 4? That is equals to 2. And that's rational because it ends. You know, we have seen quite a few irrational numbers so far. But now let's meet the famous one in the world, pi. It's everywhere in every circle. Whether it's the wheel of your bicycle, the lead of the czar, or even the shape of the moon, pi starts off as 3.14159, and then it just keeps going and going forever. No repeating, no ending, and absolutely no pattern. You might have memorized the first few digits in school, but here's the cool part. People have calculated millions of digits of pi, and guess what? It still never repeats. There's another one, E. It starts with 2.7182, and it's just like pi, never ending, no pattern. Alright, here's a super quick trick to help you figure it out just by looking at the decimal. If the decimal stops like 0.5 or 2.75, that's a rational number. If the decimal repeats like 0.333 or 0.272727, still rational. But if the decimal goes on forever with no pattern like square root of 2 or pi, that one's irrational. So always ask yourself, does it end? Does it repeat? If the answer is no to both, then it's definitely irrational. Let's try a fun one. Anaya brought some yummy parathas in her tiffin, and she decided to share them equally with two of her best friends. So that makes 3 girls in total. Each one got 1 divided by 3 of the food. Now tell me, can we write this as a fraction? Of course, it's 1 by 3. But what's the decimal form of 1 by 3? It's 0.333, and that 3 goes on forever. It repeats. So, is this number rational or irrational? It's rational because even though it goes on forever, it has a pattern. Here's another one. Megha's school has this big, beautiful round garden, and her math teacher says to find the distance around it, we use this formula 2 pi r. It's called the circumference. Now you might be wondering what's this mysterious pi is. Well, pi is 3.14159, and it just keeps going. No ending, no pattern. We can't write it as neat little fraction. So is this rational or irrational? It's irrational because pi never ends and never repeats. And that's a wrap on rational numbers. We have seen what they are, how they show up in everyday life, and how to tell them apart from irrational ones. But here's a fun question. What happens when we add, subtract, multiply, or divide these numbers? Do they follow any special rules? Well, in our next lesson, we will dive into the properties of rational numbers. We will learn some cool math shortcuts that make calculations quicker and a lot smarter.